All right, hi everybody. Well, happy Friday or happy Tuesday, depending on which group you're in. Yesterday we talked about simplifying radicals, and you may wonder where in the heck did that come from? That doesn't have anything to do with what we've been talking about. But guess what it does? So, again, I'm going to go over some forms that we've worked with. We've got standard form of quadratics. Looks like ax squared plus bx plus c equals 0. We have vertex form, which would be a times x minus h squared plus k equals 0. We've done things in factored form, where we have the two x values plus or minus their terms equals 0. We've taken equations or expressions from standard form and put them in vertex form using completing the square. And today we're going to talk about the one method of solving or working with quadratics that works every single time. If you remember factoring, we had to have some pretty numbers. If the pretty numbers didn't work, we used completing the square to take something from standard form to vertex form. But if you're actually looking for your zeros or your roots, or where our parabolas cross the x-axis, our zeros, one solution that works every time, or one formula that works every time, is if we use the quadratic formula. So I'm going to write the quadratic formula out here. And when we're back in person, Miss Tucker and I will sing you the quadratic formula song. I will not subject you to that on this video. But to use quadratic formula, we always have to start in standard forms. We're always going to need our expression or equation to be in standard form. And again, standard form is ax squared, so we have a term with x squared plus bx plus c equals 0 or equals y, depending on if it's an expression or an equation. So when we write quadratic formula, we're going to use x equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of that over 2 times a. And we're getting these a, b, and c terms from our standard form over here. So we've got our a, our b, and our c. So when we look at an equation or an expression, that is where we'll get these numbers to plug into our formula. Now, see this radical right here? That's why we did simplifying radical equations yesterday, because we need to get good at that to get good at quadratic formula. So let's try some examples. Alright, so on our first example, I'm going to go ahead and write the quadratic formula at the top. So again, we have x equals negative, and I'm going to go ahead and put things in parentheses, because when we put things in our calculator, it's really important that we put our numbers that we plug into the equation in parentheses. So I'm going to put parentheses around all the variables. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. And again, when you're going to plug this into your calculator to solve these problems, anything that's in parentheses, all of those variables that we plug into this equation, you're going to want to put in parentheses. Now I'm going to give you a little bit of a vocabulary lesson here. So this whole thing is called the quadratic formula, but there are going to be some parts sometimes when we just look at this section right here underneath the radical, and this is called the discriminant. So I want you to know that term, because we'll use that a lot later, but that is called the discriminant, just that square root of b squared minus 4 times a times c. That is called the discriminant. And the other thing I need you to know about these quadratic formula problems is, you see this plus or minus right here? You can't put that in your calculator. So this isn't something that you can just plug the whole thing into the calculator and get one pretty answer at the end. You're going to have to do this in pieces. So let's look at our first example. So example 1, we have x squared minus 5x minus 14 equals 0. And just like when we've done completing the square and a lot of other equations, we want to make sure that all our equations are set equal to 0 or equal to y. So in this case, we're already set equal to 0, so we're good to go. Now we're going to identify our a, our b, and our c terms. Now our a term is always going to have the squared next to it, our b term will always have the x, and our c term will always just be a number. It's really important that when we write our quadratic formula, when we write things in standard form, that we do those in that order. So in this case, there's no number in front of that x squared, so it's a 1, so our a term is 1. Our b term with the x is -5. It's really important that we take that symbol with it. And our c term is -14. So now we're going to plug those numbers into our equation here. So we have x equals -5. See why it's important? Our b term is already negative. We need to make sure that negative on the front goes there too. I'm going to leave the b in blue, plus or minus the square root of b, I'm sorry, not b. We know what b is. Erase that and put our 5 in. 5 squared minus 4. Our a term we're going to keep as red. Our a term is 1. And our c term I'm going to make green, -14. All of that over 2 times our a term, which is 1. So anything that I wrote in black stays the same every single time when we do quadratic formula, but I'm going to make our b term blue, b for blue, c is going to be green, and a is going to be red. Alright, so let's simplify now. So out in front we have -5. So really we can say that there's a -1 here, and -1 times -5 gives us positive sides. So we can simplify that to x equals 5 plus or minus the square root. So 5 squared would give us 25 minus 4 times 1 times -14. I can't do that in my head, so I'm going to get my calculator out and do 4 times 1 times -14 to give us 56, because we have -4 times 1 times -14, so we have plus 56, because a negative right here times a negative gives us a positive. And all of that over 2 times 1, which gives us 2. Alright, we just have a couple more steps. So now we're going to simplify what's underneath the radical. So we have x equals 5 plus or minus the square root of 25 plus 56 will give us 81 all over 2. Now if we have looked at our square root chart that I posted on Google Classroom yesterday, or if you just know this off the top of your head, you know that the square root of 81 is 9. So when we rewrite this, we're going to, this plus or minus now tells us that we have to do 2 separate problems. We have to do 5 plus the square root of 81 divided by 2, and 5 minus the square root of 81 divided by 2. So when I rewrite those again, I'm going to go ahead and simplify 81 to 9. The square root of 81 is 9, so we're going to have x equals 5 plus 9 divided by 2, and x equals 5 minus 9 divided by 2. So 5 plus 9 is 14, and divided by 2 will give me 7, so that's one of my answers. And 5 minus 9 will give me -4, and if we divide that by 2, we'll get -2. So my answer to this problem would be x equals 7 and x equals -2. And just like when we factored, those are our zeros, or where this parabola will cross the x-axis. Let's try another one. Alright, so again I'm going to start with our formula at the top, and I'll color code it this time x equals negative b plus or minus the square root of b squared minus 4 times a times c, need to make my radical a little bigger, all over 2 times a. Alright, so let's look at our next problem. This one's going to look a little different. Our example we're going to write is 2x squared minus 3x minus 5 equals 0. Alright, so we're going to look for our a term, our b term, and our c term. This time there's a number in front of x squared, and that's a 2. So our a term is a 2. Our number with our x is negative 3. I shouldn't write that like that. b a equals 2, b equals negative 3. That a looked negative there for a second. And c is negative 5. So now we plug this into our formula just like before. So we have x equals negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 5. See, I'm matching my colors up, making sure that everything in the equation matches up the colors that I wrote on top, all over 2 times 2. Okay, once again we're going to simplify. On the outside we have a negative 1. Oops, I don't want it to be red. Let me erase that. It's not a number there, we can assume it's a 1, so negative 1 times negative 3 would give us positive 3 plus or minus the square root. Negative 3 squared would give us 9. And then we have negative 4 times 2 times negative 5. So that's going to give us plus 40 all over 2 times 2 is 4. Now I skipped this part last time, but let's look at our factor, what we have underneath our radical. 40 plus 9 which gives us 49. If we do our factor tree, 49 is 7 times 7. So we can write it as 7 times 7, and we have 2 7s, so it can just come out as 7. So we have x equals 3 plus 7 divided by 4, and x equals 3 minus 7 divided by 4. So this time the numbers aren't as pretty that we get at the end. We're going to get x equals 10 over 4 or 5 over 2. And x equals, so 3 minus 7 would give us negative 4, and negative 4 over 4 would give us negative 1. So these are my two answers for this problem. Alright, one more example. So what does it look like if we would have, actually let me go ahead and write my equation first. We have x equals negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. Alright, so what if we have one that looks like this? What if we had 5r squared equals 80? Well, first of all, it's not set equal to 0. So we need to go ahead and move things around so that it is set equal to 0. So we have a positive 80, so I'm going to move the 80 over to the other side. And that gives me 5r squared minus 80 equals 0. Well, if you remember our formula, we have ax squared plus bx plus c. So we have our x squared term and we have our number term, but we don't have a term in the middle that has the x. So if it helps you, you can rewrite this as 5r squared plus 0x minus 80 equals 0. So then when we label, our a will give us 5, our b is 0, and our c is negative 80. So once again, we plug this into our equation. We have x equals negative 0 plus or minus the square root of 0 squared minus 4 times 5 times negative 80, all of that over 2 times 5. Alright, so when we simplify, x equals, well, 0 can't be negative, so we're just going to put 0 plus or minus the square root. Alright, 0 squared is still 0. And then we've got negative 4 times 5 times negative 80. So 4 times 5 times 80, because the negatives cancel out. 0 plus 1,600, a big number. All of that divided by 10. Alright, now 1,600 is not a perfect square that we've talked about at all, so you might want to get your calculator out now and just do the square root of 1,600. So that's going to give me 40. So then we've got x equals 0 plus 40 divided by 10, and x equals 0 minus 40 divided by 10. See why it was important to keep that 0 out in front? Usually we could just get rid of a 0, but we have to add and subtract. So our first solution is going to be x equals 40 over 10, which gives us 4, and x equals negative 40 over 10, which gives us negative 4. So as we go along, we're going to have some parts of the discriminant that we will have to simplify like we did yesterday, but for today we're just going to work with some pretty quadratics that give you a whole number, but get ready for simplifying more radicals later.